Okay, in this video lesson, we'll be doing an introduction to limits. So we'll look at a situation like this. We have this piecewise function here, where we have a quadratic function and a constant. And so if I was to graph first the quadratic, we have our parabola. But notice the constraints. It says x does not equal 2. So here's where 2 is. So it's shown, we'll show everything except this one point. So in essence, we somewhat remove this one point from the parabola. Next, we'll draw the constant function. So a horizontal line going through -3. But we notice the domain says we only want x to equal 2. So we only want this one point here. So our piecewise function, f of x, has this graph here. A parabola without one point and a single isolated point at -3. So if I was to determine f of 2, well, 2 exists in the second function, the constant function. So f of 2 is at that one point. F of 2, the y is -3. But we'll consider a scenario in which we hadn't seen before. Let's consider what happens as we approach the 2 in the f of x. There's a special way of writing what we want to do here. It's called limits. So what this reads right now is the limit of f of x as x approaches 2. So what we're trying to determine is there a trend in our graph as we get closer and closer for x equaling 2? Is there a trend that the y is approaching? And so if I approach 2 from the left, it looks as if the parabola is getting closer and closer to the number 4. And if I approach it from the other side, it also appears that it's trending toward that one open circle, or that one removed point. So in this case, the limit of f of x as x approaches 2 would be 4. So 4 says there's a trend. As I approach the 2, the trend is the y is getting closer and closer to 4. So in essence, limits describe how a function behaves near a point instead of at the point. So in the green earlier, we discussed what is happening at x equaling 2. Limits speak about, well, what's happening as the picture gets closer and closer to 2. So we'll consider this function. We have a line, which looks like we have a point removed, but a single point off the line. So if I wanted to know what's happening to this function as we get closer and closer to the number 3, which is getting closer and closer to that open circle, how would I write that? The limit of f of x as x approaches 3. So if I approach it from the left, looks like I'm getting closer and closer to y equaling -2. As I approach it from the right, same thing. Looks like it's approaching -2. So the limit of f of x as x approaches 3 would be -2. Another scenario. Here again, if I wanted to know what's happening in the function as we get closer and closer to 3, how would it be written? The same way. Limit of g of x in this case, because it's a different function. Limit of g of x as x approaches 3. So I'll look as I approach 3 from the left. It's getting closer and closer to this point. The point is 6 on the y-axis. And if I approach from the right, I'm getting closer to a different point where y is 1. So in this case, there is no trend toward a specific location. If we look at it from the left, we're trending toward one location, and as we trend from the right, we trend toward a different location. So here, the limit would not exist. So let's look at another scenario. So here, another piecewise function. And so we'll consider all of these different scenarios. So the very first one says f of 1. We're asking what is happening at this point. What is happening when x actually equals 1? So that puts us at this point. well, it looks like the y is going to be -2. But the second scenario says, well, what's happening as we approach +1? So if I approach from the left, looks like we're going toward this point here, which is that the y is -2. But if I approach it from the right, I'm leaning toward this other point here, which is at +2. So in this case, the limit of f of x as x approaches 1 does not exist because we're not trending toward the same location. Now with f of 3 says go to the 3 for the x, which would put us at this point here. Well, it looks as if f was 3, y would be 4. However, because it's an open circle, that's saying that point is not part of the function. So here, there would be no solution. Again, because it's an open circle, that point is not part of the entire function. But when we look at, well, what happens as we approach the 3? So as we approach from the left, it's going toward the 4. If we approach from the right, it's trending toward that same 4. So here, the limit of f of x as x approaches 3 would be 4. So seeing these side by side, you can see how they're different. One says what is happening at the number. This is saying, well, what is happening as we get closer to that particular number? One more, f of 5. Well, 5 is saying what is happening at the 5. Notice we're not looking here because there's an open circle here, closed circle here says this is the one where 5 actually exists for the x. The corresponding y would be -4. But now the next says, well, what is happening as we approach 5? Well, if we approach 5, we're actually on the linear absolute value piece of this function. So as we approach from the left, we're going toward the 2. As we approach from the right, we're also going toward that same 2. So the limit of f of x as x approaches 5 would be 2. So this graph here kind of illustrates all the various scenarios you would see. So what we're going to now do is change our conversation. We're still working with limits, but something more specific to vertical asymptotes. So in this function here, which is probably rational, we have several vertical asymptotes. One at -2, one at 1, and another vertical asymptote at 3. So we'll consider, well, what's happening as we approach these 3 different vertical asymptotes. So when we consider the limit of f of x as it approaches -2, we have to consider coming from both the left and the right. Well, there's a special way to illustrate coming from the left and coming from the right. So here, this says the limit of f of x as x approaches -2, but this right here says we'll approach it from the left, as opposed to here where it says approach the -2 from the right. So this is being more purposeful about finding the limit. It says in order to find this limit, I have to consider coming from both directions. So when we considered the first, approaching the -2 from the left, the graph is going toward positive infinity. So the limit of f of x as x approaches -2 from the left, positive infinity. If we approach it from the right, it's approaching negative infinity. So that's the trend. And because these two are different, it's showing that there is no actual trend as we go toward -2. So by actually illustrating what's happening from the left, what's happening as we approach from the right, we can see definitively that there is no trend as we go toward the -2. Let's do the same thing with the 1. We're going to illustrate what happens as we approach from the left. You can see it's going closer and closer to negative infinity. And if we approach from the right, it's moving up toward positive infinity. So the limit of f of x as x approaches 1, as we can see, from the left and the right aren't the same, so there is no trend, does not exist. And the last one, we'll consider approaching 3 from the left and the right. From the left, the graph is going up to positive infinity, and as we approach from the right, it's also going up to positive infinity. So here we can see there is a trend toward positive infinity. Next, we'll consider limits within behavior. So with this one, we've got our linear function. If we consider what's happening as we approach each end. So here we have the limit of the function as x approaches negative infinity. So we're moving to the left. We can see and corresponding it moves downward to negative infinity. As we move to the right toward positive infinity, it's also going up to positive infinity. So here the focus is just what's happening at the ends of the function. Here we have a radical function. The limit as we approach negative infinity, so we're going toward the left. And it seems as if it's approaching, not going down forever, but it's approaching 0. Whereas if we approach positive infinity, it appears to be going upward, also to positive infinity. One more example. H of x equals 1 over x, which is our rational function. And so when we graph it, if we approach negative infinity, the problem is going upward to 0, to that horizontal asymptote. If I did the same thing with the limit going toward positive infinity, moving to the right, it's also approaching that same 0. So in this case, the limit is approaching our horizontal asymptote. So we've got two examples here. These are all the different scenarios you would have to answer. It talks about what's happening in the middle of the graph and what's happening at the ends. So the limit of f of x as x approaches 1 from the left, it's going toward the negative 1. As we approach it from the right, it's also going toward the negative 1. So therefore, the limit of f of x as x approaches 1 will be that negative 1. Now, here we're asking for what's happening at the 1. Well, at the 1, we're on this point, which would be at positive 4. Now we look at the ends. As I move to the left to negative infinity, it's going down also to negative infinity. If I move to the right, it's also going down to negative infinity. One last example. So we'll consider the various components here. As we approach 0 from the left, we can see we're going toward this open circle at 1, my apologies. So as we approach from the left, 1. As we approach from the right, we're no longer on the linear absolute value, we're now on the line. It approaches this point at 3. So here we can see there's no trend. So the limit of f of x as x approaches 0, it does not exist. But when we look at f of 0, notice 0 occurs in two separate places, but at neither of those places does that point exist. So here it's no solution. And last, looking at the end behaviors. If we approach negative infinity going toward the left, the graph is going upward to positive infinity. And as we go to the right, notice it remains constant. It seems to be approaching 3. So this scenario has some unique situations. So with these two different examples, hopefully this will be enough to get you going with the practice.